In this lecture, we are going to take a look at another of Python's important data types. We have already taken a look at lists in some detail over the last few lectures. Today I'm going to take a look at strings. Of course, we have already seen strings. Strings, remember, are just characters, letters, numbers, special characters, whatever, put within quotes. So a string which I'm storing in this variable called s can be something like this. Of course, a string could also have other characters in it, including other special characters, including an apostrophe or a quote in it. But just remember, a string has to start with a quote, end with a quote. What kind of quote? The same kind. So a string which starts with a single quote has to end with a single quote. A string which starts with a double quote has to end with a double quote. So if I want to write something like Stargazer's telescope, so if I wrote this, sorry, the extra B is there. So if I wrote this, then I'm going to get an error. Why? Because remember here the quote, the single quote, is a string delimiter. What it means is that it helps you to start and end a string. So here I've started a string here, and Python is blissfully unaware of the details and intricacies of the English language, so it does not recognize that this quote sign here is really not a quote sign at all. It's an apostrophe. It's just going to treat it like a quote sign, because that's what the symbol really is. And what it is going to do is it's going to end the string then and there. And once the string has ended, if you write an S right after that, Python simply has no clue what that means. So let's see what happens if I try to assign this to S. Now Python is trying very hard to figure out what happens, and then it says invalid syntax. It's telling you clearly where the syntax is invalid. It's telling you that this S isn't where it should be. Of course, you know that this S is correct, and the quote in front of that is the apostrophe which you meant. So if you really wanted to write that, one way would be to start and end not with a single quote but with a double quote. And then, of course, for a string which starts with a double quote, the ending has to also be with a double quote. So then Python does not think of this as an ending mark, ending character for a string. It just takes it to be part of the string and happily takes the whole thing as a complete string. No problems whatsoever. Of course, if you wanted to write a double quote inside your string somewhere, maybe you're quoting somebody, then again, no problems. You begin the string with a single quote, end with a single quote. But there could be other problems. Like, I could really need both a double quote and a single quote inside the body of my string sometimes. And then, of course, no matter whether you start with a single quote or with a double quote, you are in trouble, because the matching double or single quote inside the body of your string will cause the string to end, and the rest of whatever you write is going to give an error. So how do you handle that? This brings us to the notion of something called an escape sequence. Realize that the quote symbol here has a special meaning. It's supposed to mean end the string or begin the string. It means that this is a string delimiter in its usual avatar. Now, what an escape sequence does is that it helps a character escape is usual meaning. So for the quote, the usual meaning is that of a string delimiter. If you escape its meaning, then its special meaning is gone. It's no longer a string delimiter, it's just the quote character. Now how do you write this escape sequence? And the answer is, this is a very standard thing. In many programming languages, you just put a slash in front of the character whose meaning you want to escape. So what is this now? You have started a string with the double quote. Inside you have a single quote which is no longer a string delimiter because you have escaped its usual meaning, that of a string delimiter, by putting a slash in front of it. So now you have an escape sequence slash followed by a single quote, and the meaning of this escaped character is simply its usual, not its usual meaning, but its usual self. Here it just means the character quote. So there will be no trouble. Now of course you might say there wouldn't have been any trouble anyway, because we have started our string with a double quote. So in this case the delimiter is not a single quote anyway, it would have been a double quote, and you would have been right. But notice that if I'm using the escape sequence, I can actually use single quotes as well, because now this single quote is a string delimiter, the one at the beginning. This single quote is again a string delimiter, the one which ends the string, the one at the end. But the single quote in between here no longer has a meaning of a string delimiter, because now this single quote is no longer alone, it's part of an escape sequence. So just notice that if I hit the enter now, there will be no problem, and the string S will have the quote inside in its body. Of course, when I want to see what's inside, Python will simply take the easy way out and use double quotes to delimit the string, so that the quote inside is not a string delimiter. The important thing is, if you use an escape sequence, and you can change the usual meaning of a character. Now, not all characters are parts of escape sequences, but there are plenty which are actually quite useful, and some of them you need to know. You don't need to memorize all of them, of course, but there are quite a few which are quite interesting and important. For example, I'm using an escape sequence /t here. T, of course, has no special meaning of its own, it's just the letter T. But /t now escapes the usual meaning, which is that of just the letter T, and becomes something special. You will see what soon. Okay, let's see what is now inside S. Well, no surprises. It's */t Geza. And since there are no double quotes inside, Python simply uses a single quote to delimit that in its representation, in what it's showing you. No problems. But let's try printing this out. And to print, you have to invoke the function print, and in Python 3 it's a function, so you have to write print followed by a round bracket. Inside the round bracket you have to give the argument, whatever you want to print. There are some more subtle points about printing with special formats and so on. We are going to tackle those issues later. If you are using Python 2, you would just have to say print blank S. So their print is more like a command. You just say print followed by a space followed by whatever you want to print. In Python 3 onwards, print is really more like a function. It is a function, and this is one of the common situations where Python 2 and 3 differ. If you are using Python 3, of course you will do exactly what I am doing right now. Now notice what has happened. In the printed version of this string, you do not see the /t character. What you see instead is some big space. And this should tell you what slash t really is. Slash t is what is called a tab character. It makes the next character in the string move to the next available tab stop. How big is a tab stop? That depends on your system, but most systems it's 8 spaces. So you had your beginning tab stop was at the very beginning out here. Then you have 1, 2, 3, 4 characters. Then you will have 4 more spaces to make it total of 8 at all in all. And the next character in the string G moves to the next tab stop. So slash T is an escape sequence which simply means tab. Just to see whether that's correct, let's put a bit more. Note that I'm not even bothering to put a space after slash t before I start the next word, because slash t is going to take care of the tabbing. It's going to produce enough spaces of its own. So let's print this S once again and see what comes out of this. The spacing here is of course bigger than the spacing here, but that's because the tab character only moves to the next tab stop. So from here to here is exactly 8 characters, 4 spaces because star only has 4 characters. Gazers on the other hand already has 7 characters. Remember, the quote is also a character. So G-A-Z-E-R, that's 5, then a quote, then an S. So this already has 7 characters. To get to the next tab stop, there's only 1 more required. So there's only 1 more space here. So that's how slash t works. Another important escape sequence that you will need to know to use often is something like slash n. Again, n has an usual meaning, the character n, but slash n escapes that usual meaning. It means something new. Let's see what it means. Again, to see what it means, you will need not to just see what's inside S this way, because that will just show you slash n's everywhere. To see what is inside S, what the meaning of the slash n is, let's try printing S. And now you see what has happened. The slash n actually has this meaning. It's a new line character. Because it's a new line character, gazers, telescope, these move on to a new line. Notice slash n, slash t, space, all these things, they are all characters. They are called white space characters for one reason. They are simply they simply don't print anything out when you try printing the string. They just leave spaces, tab spaces, move the entire blank line moving on to the next line, or just plain white spaces. So they are all together called white space characters. That's a name that we will need to remember as we go forward. Now, is this all about escape sequences, or are these the only escape sequences possible? The answer is no. There are many, many more possible, but frankly, nobody remembers every one of them. But there's one more which actually will come in very handy, which is this. Suppose I ever wanted to print a slash, or I wanted to have a slash inside my string. Trouble is, the slash itself is a signifier that whatever comes next forms part of an escape sequence. Slash is the escape sequence character. So the moment you put a slash inside your string, the meaning of the next character gets changed, and the trouble is, then it's no longer what you may want, because you may want to have slash as a character itself. For example, you may even want to say this. Like quote slash quote. is or starts an escape sequence. Okay, fine, no errors, this was stored properly, but let's now try to print s and see what happens. Well, the slash has simply disappeared. Instead, you have two quotes sitting in the middle of your thing. Well, that's easy to understand. After all, slash begins the escape sequence, which makes the quote after the slash, not the one before it, but the one after it, forget its usual meaning of string delimiter and behave just like an ordinary quotation mark. Of course, in this case, because you started the string with the double quotes, the single quote was not a string delimiter anyway, so that wouldn't have mattered. But the important thing is the slash character has no meaning of its own, because it has a special meaning, and that is not the character itself. That is what is causing it to disappear here. So what would I do if I really wanted the slash character to show up there? Well, you have to escape the meaning of the slash character. And how do you escape the meaning of the slash character? Simple. You make it part of an escape sequence. So you start with a slash, you're beginning an escape sequence here, and after that, put in the slash whose meaning you want to escape. So notice the second slash, which should have been the starting point of an escape sequence, has its meaning escaped because it follows the first slash. So now the second slash no longer means the starting point of an escape sequence. It simply means something else, and that something else is, it simply means whatever its character is. So now let's see, what is printf now? This is exactly what we wanted. So if you want to print a slash inside your string, you would need a double slash. But well, that's a rather unusual situation. You would usually not want so much to print a slash inside. But the new line character and the tab character are both very important. You may need to use them over and over again several times. Now, let us take a look at some other properties of a string. Okay. Now, some of the properties of a string are properties which every iterable has. It's not really a property in this case. It's a function, a built-in function which is available to you whenever you start Python. And this built-in function len gives you the length of an iterable. So here it says 49 is the length of your string s, which would be the length if you start counting from the beginning to the end, remembering to count the quotes, the spaces, and all of them. So len here tells you that your string s is 49 elements long, and you could, just like in any iterable, you could access individual elements by using square brackets. That's how you access elements. So 48 here is of course the index of the very last character, which of course here is e. You could use a slice notation, which in this case would mean start at character number 20, element number 20 of the string, take every element after that, but don't touch element number 48. So from 20 to element number 47, that is what you would get. You get a string made out of those, and this is what comes out. Of course, because you are ending, your stop value is 48, so you are ending before 48, the e doesn't show up. I am not going to bother counting to show that this single quote here is actually the 20th element, but you should be able to easily convince yourselves, if you have the time, that is, to count and check that that is really what has happened. So you can have slices. You can also of course have slices with increments. So this will be element number 20, which was a quote, then element number 23, 26, 29, and so on, and of course stopping before 48. So this is very similar to what you had in this. What you have different here is something like this. If S had been a list, you could have done something like this. And that would have changed the 48th element of a list S2 so that it now would have contained the string quote F. But with the string, that simply cannot be done. Notice what kind of error you are getting. You are getting a type error. Here the type is not of this object whose type you are trying to change. It says str object does not support item assignment. You cannot assign a value in a given position to a string simply because a string is immutable. Once you create it, you cannot change it. That is what it has in common with tuples. So just like lists, you can slice, you can index, you can use a len function on it. But this is where it differs from lists. You cannot assign values to individual elements. Once it is created, it stays the way it is. Once again, let me repeat. Lists are mutable, strings are not. And let me remind you that tuples also are immutable objects, things you cannot change once you create them. Fine. What else can you do with strings? A lot, as it turns out. And of course, I could do something very similar to what I did in the last video. Open up the help for strings, go through the entire list one by one and demonstrate each and every one of the string methods to you. Frankly, that would be too much of work, because unlike lists where the number of methods available, leaving out the crazy ones with double underscores in their names, of course, the other more decently named methods were rather few in number. We could cover all of them roughly in one video. Here for strings, on the other hand, we have quite a lot more of string methods, as you can easily convince yourselves by opening up help for a string. And frankly, it's not worth learning about all of them. Some of them are actually quite advanced things and it will be difficult for you to understand them at this time. But even if you leave that out, nobody really memorizes all possible methods of an object. All you need to know is a few more important methods. So in the next lecture, what I'm going to do is I'm going to actually take a look at some list methods, string methods, sorry. I'm going to open up the help, pick out a few of the string methods, not all of them, and discuss them one by one so that you get familiar with the ones which you really need to be familiar with. It's of course also a good idea to skim the help at least quickly so that you are aware of what other methods are also available, so that if and when you need them, you can use them, or you can learn about them just by going into the help. Now today, what I'm going to do is I'm going to use a very small number of string methods which are tied to strings, which actually gives you quite a lot of power. Of course, this is just an introductory lecture today, so I'm going to go slow and talk of only a very few such methods. But the first one I'm going to talk about is not even a string method. It's a method, or it's a function, it's a built-in function which, like len, acts on a string. But unlike len, which could act on any iterable, this one expects its argument to be a string, and this is called eval. And what does eval do? Well, why don't we try help to figure out what eval does? Sorry, the name is eval, says evaluate the given source in the context of globals and locals. The source may be a string representing a Python expression or a code object as returned by compile, etc., etc., etc. Doesn't really make much sense to me right now, or I don't expect it to make much sense to you at this stage. Later on, near the end of our lecture series, we will come back to this and try to understand every word of what this help means. But one part is sort of familiar. The source may be a string representing a Python expression, and this is the one part that's important for us. So let's try seeing what that means. A Python expression could be something like 1 plus 2. That of course is easily calculated or evaluated by the interpreter to give you 3. Or it could be, say, 10 to the power 200. Again, something which the interpreter can easily evaluate. Okay. Now, what happens if you have a string with this expression? Say you have the string 1 plus 2. Then it's just the string 1 plus 2. 3 characters, 1, the plus character, the 2 character. Nothing else. Python does not interpret this as a command to evaluate or calculate something. It just takes it as any other string, a bunch of characters placed one after the other. Or 10 to the 200, if this were put in quotes, that would be a string, and Python would simply treat that exactly like a bunch of characters. 1, 0, followed by a star, followed by another star, followed by 2, followed by 0, followed by 0. Okay. Now it's in the context of things like this, strings which without the quotation signs would have looked like Python expressions, and which without the quotation signs Python could have calculated or evaluated. That is where eval comes in. By now you should be sort of should have understood what eval stands for. Eval stands for evaluate. And let's see. Take the function eval, give to it an argument, a string, which it can calculate with, which the argument is a string, but inside the string what you have is a Python expression, and eval simply evaluates that and returns the result. So it gives you 3, which this 3 is not a string, it's an integer. It's just what the expression 1 plus 2 evaluates to. Okay, but what good is this? Why couldn't we just drop the strings and write this directly? You will see there are very many situations where strings come out naturally out of results, and you can combine these strings together to make more and more complicated strings, and this way you can build up very complicated expressions and then use eval to calculate them. Very complicated is not necessary. You can also evaluate simple expressions with this, but what I wanted to say was there are situations where you can create the expressions that you want to evaluate by combining other expressions, and for this, string manipulations, the things we will learn that you can do with strings, will turn out to be very, very handy. Today let me just show you a very simple example of this, but for this we need to know a bit more of string handling. Let's start with some arbitrary integer. Let's say 2, 3, 4, 5, 6. Let's say I want to add up all its digits. Now we all know how to do that. It's simply 2 plus 3 plus 4 plus 5 plus 6. But how do I tell Python to add 2, 3, 4, 5, 6? I will have to first tell Python how to extract the digits 2, 3, 4, 5, 6 from it. Again, a problem at school level. You all know how to get digits out from a number. You just divide by 10, take the remainder, that's the digit and take the quotient, divide by 10 again and keep on going, right? In fact, the good thing about this is if you were using some other number system, not base 10, but maybe base 2 or base 4 or base 8 or whatever, then the same method would work. But for the time being, let me show you a quick way of splitting up this number into its digits. Well, we have already seen that in the last lecture. We saw in the last lecture that we could split up a string into its component pieces simply by doing this. So this, remember, is list comprehension at work, something we talked about in the last lecture. What this is doing is simple, is taking the x in apple, that means x goes through every character in the string apple in sequence, and makes a list with x in it. So with x as the element. So you just split up the list. So can't you do x for x in n, where n is this 2, 3, 4, 5, 6? So it turns out that you can't, simply because for this list comprehension to work, you need an iterable object, an object from which Python can take pieces out, and those pieces are what is going to become x at every stage, and that's going to be used to calculate what the terms are going to be in the list. But the int object is not an iterable. It does not come in pieces. It's a single entity. But let's not stop at this small hiccup. You could convert the integer n into a string simply by using a function, again a built-in function called str. What does it do? It changes whatever you give it into a string. So now strn is not the integer 2, 3, 4, 5, 6, it's the string quote 2, 3, 4, 5, 6 quote close, and now this is going to work out. You have split up the entire thing. But how do you add them again? For that, we will need the help of a special string method. This method is called join. So what does join do? Let's show you what it does. Join is a bit of an unusual method. It acts, it's a string method, so it's tied to a particular string, and it takes a list or any iterable, not necessarily just a list, which contains strings as arguments. That's important. The list or the iterable has to contain strings as its pieces. So let's take this list first of all. Let's save it in a variable L, and then I'm going to give this L as the input to the join function. The join function has to be tied to some string, right? Now let us do this. Let's take the string to be plus. So this of course is not the plus of the addition operation. This is string with plus as a character. But you want to tie the join function to that. So it's plus quote within quotes plus dot join. So this join is now tied to the quote plus quote string. And let's give L as an argument for that. And let's see what happens. Notice what has happened is the elements that were in the list L, which are nothing other than the string 2, string 3, string 4, string 5, string 6, as 6 different elements. Join has just joined them together. But the self in this operation, the string to which join is tied, what does that do? That becomes a glue in the joining. It just is what you put in between the different list elements and to join them together. So now you have this string 2 plus 3 plus 4 plus 5 plus 6. By the way, you may have actually noticed by now that there is a simpler way of doing this for our particular problem. Instead of creating this list by splitting up the string strn, why don't we give strn itself as an input to this join function? This should also work because what join does is takes the pieces of the iterable which has been provided to it and joins them with whatever glue you are providing, or whatever glue the self object for this join is. So in this case at least, you did not have to split them into individual elements, put them in a list and then join them. You could have just used join directly on strn and this would have worked. Fine, so now I have a string 2 plus 3 plus 4 plus 5 plus 6, but I don't want that. I want to calculate the result of 2 plus 3 plus 4 plus 5 plus 6. How do we do that? We know how to. We should actually use eval on the string that was the result that we had. Now let me show you a tiny trick which works on the interpreter. If you have calculated something on the interpreter but have forgotten to store it in a variable and you need it again, it would be a bit of a waste to actually have to calculate it all over again just to store it into a variable. After all, Python just did the calculation. Has it thrown away the result? The answer is no, it really hasn't. You can still access the last result that Python has calculated by using the underscore character. So this is a trick. You of course could have written down the expression once again, but right now what I am doing is I am using the last result, quote 2 plus 3 plus 4 plus 5 plus 6, the string. I am using that as an argument to eval by using the underscore special character. And eval just evaluates. So you get the sum. So that's it. Is that the only thing you can do with eval? The answer is no. You can do a lot more. You can do many more complicated things. In the next lecture, we are going to carry this forward and see how we can creatively use join and some other string methods together with eval to get some very interesting calculations done. Until then, goodbye.